What's good, everyone? Welcome back to Cloud Core Hub. So today we are doing something a little different. We are not just going to talk about how to use one AI to write code. We are talking about what actually happens after that, after building something. Because here's what I keep seeing. People are using these AI tools. They are building things faster than ever, apps that really looks great, apps that actually work, and then nothing. It never ships. It never reaches any end users. It just sits on their laptop, and I've also been there too. So in this video, we are going to fix that. We are going to plan a quiz app from a raw idea all the way through planning how to build app, building the app, and how testing, deploying, and also running your app in production. It's just going to be more of teaching, not showing. Maybe in my next video I will show you demo how to do this from end to end. So every stage, by the end of this video, you're going to have a complete picture of what separates someone who vibe codes from someone who actually ships. All right, let's get into it. Everyone has an idea. You have your idea, I do, we all have idea to build something, infinite ideas, but we don't really start. How do we start building it? And if we start building it, how do we eventually ship it? Or how do we make sure that our code is really good? So we have 12 stages of SDLC. I'll tell you what that means as I go along. And you have to master how to do your software from the beginning to the end. There's no end, is continuous, is always running. But how to plan it? I will start. So what is software? Is a set of instruction or logic or data. It's just layers of instruction that you give to something, which is a computer that runs in a computer. So soft is something that you can see. So this is a hardware, but every application that runs on this phone are all softwares. So it's not tangible. So it's set of instructions. So you open your quiz app, for instance, you click okay, start quiz. Or the quiz app itself is a software. So it's a set of instruction and logic and data, that you ask the computer to do something. So you click something, something happens in the back end. So for softwares, we have something called, front end, we have back end, we have the database, and we also have, the infrastructure that hosts the software, and we have the operation. So operation is more like application is now running, or the software is now running. The process of that run process, or the run process, is now called the operation. All right, so I will go to the next one. What is vibe coding? Most interesting question. Vibe coding is more like using natural language to give an AI tool to help you build something. I can call a set of engineers, or call people, a team of developers, and say, I want to build this app. I want you guys to build this app for me. Then they will sit down with me and start asking me questions about, do I know, like, what do I want the app to look like? What is this app for? Who are the end users? Is this app for kids? Is it for men? Is it for women? Is it for older generation? They will start asking questions, because things like that will help them determine the tools or the visuals, or how they want the app, or how the app will look at the end of the day. But vibe coding is just telling a tool. Now it's not a set of people, but telling a tool that acts as an agent to a lot of developers, this is what I want. I just want a quiz app. That's simple. Like, I want a quiz app. Then maybe we can start going back and forth into, this quiz is for everyone, or the quiz is trivia, or the quiz is about geography, the quiz is about entertainment. You can start giving information like that, or you can let it know that is everything. I just want everything, or maybe give it categories. So is an AI assisted development. So you tell the AI what you want. But one thing with this type of build is that there are hidden tension. There are hidden things that you don't know. You just give a prompt, it generates code, but most times we don't even know what is in this code. Well, I'll keep going. So what is software development lifecycle? Is from the idea until the application is in production. That is the whole life cycle. So from the idea, it goes down to the application running. So you start with, planning. This is the time I sit down with set of engineers or developers to tell them this is what I want, and we go back and forth on questions on, the structure, who is it for, what do I want. Like anytime people select the app, are they able to answer, select how many questions they want to answer. Is it going to be 10 questions as once, or 20, or how is the response going to be? Is it going to have options A, B, C, or do you want them to just tap a button to select the correct answer? Or how Kahoot is, you can you can tap on the green or red or yellow button, or you can even tap on something that shows that this is the answer you want to select. So this is a stage where things happen, people plan. Then the second one is start to design. Designing is more like the front end, what is going to look like, what is the database going to look like. So the database, are we looking at multiple answers, or things like that? And after that, there is the build. So the build process is now when they generate the actual code, where, well, for vibe coding is also like the time they start building the app, or the AI tool starts building the app. Also, this is the time where the developer starts building the app. And after they are done building, the next, or still in the process of build, there's something called test. So test cases is you test your app. Does it really work? When you say does it really work? Yeah, it should work. But let me give you an example. If I'm doing a test, if I'm doing a quiz that has 10 questions, so each of those questions, do I want that for each correct answer will be 10, and means if I have all 10 correct, I'll have 100. What if I come back to the app again? Does it still keep my score of the last quiz and add it to the next one? So this is the time you start telling your app what to do and what not to do. So once this quiz has finished, don't show this set of quiz to this same person again, so they don't have to redo a quiz that they have done. Or if they answer quiz and they fail it, do you tell them the right answer, or things like that? Or when they finish, or if they take time to respond to a quiz and get it right, do you reduce their score based on they took their time to respond to that answer? So these are things you start testing, and start testing the logic. Do people have to see other people's score? Start building structure around your code. Then there is the next one, that's a fifth step, is the deploy. So this is where you move the code from your laptop to infrastructure. You're sending it down to the reusers. You deploy. And well, you build a code, you build an app, you deploy. People think maybe that's the end. No, that's even the fifth, or like the middle stage of the SDLC. You deploy your app. This is where your users start using it. It could still be at your testing stage that you want people to test the app and give you feedback. But let's assume that at this point you have deployed your app to somewhere, an infrastructure. Maybe if it's on-prem, it could be deployed in a data center. It can be in the cloud. There are so many cloud services, the AWS, the Azure, GCP, and there are other tools that you can deploy, or cloud tools that you can deploy your application in. Here comes the operation. So this is where monitoring, metrics. When you have your app running, it's essential that you monitor your app. When I mean monitor, is you monitor the performance. How long does it take the app to load when your users are using it? If I open an app and it opens immediately, it makes it user friendly. I love things when it is fast. But when I click an app and it takes couple of seconds to open or even longer, you get frustrated. So if you have another option, you could go with that is faster. So you start checking the latency, checking the availability. And if I have my app deployed in the US, other people in other region, are they able to access it easily? So you start monitoring and checking the performance, and know that your application is in the cloud doesn't mean it is invisible. It means it is running on a computer in the cloud. So it's running on a computer somewhere that you don't know. So it's running, and one thing with your computer, when your computer is really the process, there are so many processes running, your computer can really get hot, your computer can get slow, and you have to start looking at, the CPU usage, is it going very high, the memory, is it going very high? So you start monitoring all those metrics that's and collecting logs from your application. That's your application performance monitoring. You start tracking your uptime in production. And the next is improvements. Now, the improvements now comes from the result of your operation, or from the result of your logins and metrics. If your CPU is always going too high, or you have a spike of users, maybe 10 people were using it, all of a sudden 1,000, 100,000. So it means if your application is running just on one computer, well, it's time to improve, it's time to scale, it's time to tell your system or your infrastructure, I can't just be running my application in one system. Maybe I have to start running them in several systems because my users are increasing. Then secure, this is the most important part. Your application has to be, secured. If you're running your application, do you have authorization system, like authentication system, where people have to be authorized to enter or authorized to use it? Or is it just open, like anybody can enter and go out? So this is what happens with security. Like in your home, is everyone allowed in or not? And if you have a lock, like you have a code that people will use to enter, who has that code, and how would they use it to enter your application? And scale, this is where you have seen how your application is running, and you can now start scaling, making it bigger. If you're only serving one region, you can start serving several regions. Or you can also have, instead of just having it in one region in the cloud, you can decide to have it in several regions, so your users in other regions can reach it easily. The next one now is, thinking about from the thought to the problem definition. In this case, we are using the quiz app, and, we start, I want to build something. This is what I want. I want to build a trivia app, like a quiz app. And I also start thinking about who are the target users. Are they kids, teenagers? It's really important because of the kind of questions that they will be exposed to, or the kind of questions that their knowledge should be able to take, or their grade, or is this for older people, or is this general, like everyone? You really have to, sit down and talk about this. And you also have to decide, what is your success criteria? What would I say at this point my application is successful? What is the strong start? You can say a quiz app for students and casual users to answer 10 timed multiple choice questions. So this can be your good start, or the prompt you can use to start this quiz application. Then you also look at the feature scope. What is this, smallest useful version? And you also look at the constraints, the time, and the budget. It's really important. When I say time, I mean, well, I need this app for something. Maybe I want to do something with friends, and I need this app to be up and running by next week. So I have to think about that time. But if it's endless, well, you have to also make plans for it, and also think about budgets. What if I have nothing? Then you have to start thinking about, what are the tools that are open source, that are free, that I can use to build this? And what are your limitations? Like, what tech stack or what tech tools do you have available to you, and the ones you don't? Then we'll look at, we have to define the MVP. MVP is the minimum viable product. The minimum viable product for this, our quiz app, is user opens the app, They select a category, they answer 10 questions, they submit the quiz, and they see their score. And they review their correct answers. This is the simplest. This is the minimum that your app can do. So this is all you need to build at the first stage. What you shouldn't be thinking about in this first phase will be social media login or the leaderboard to see scores of other people and to see multiple play mode and the payments, AI generated questions, budgets, and analytics. All these are good. They are features you can add in the app much later. So if you're building an app, you have to first of all know your MVP. What is the minimum viable product? If I'm building a social media app, I have to say, people should be able to go in, create a profile, and they will see the profile that they have created. This is the minimum. Yeah, this is good. Then we can now start talking about security, authorization, authentication. Who can I see? Who shouldn't I see? Things like that now becomes features you can add up later. Then now we go to the architecture. You now start thinking who are the users. Is this going to be in the browser? Is it going to be a web app, or is it going to be a mobile app? You now think about your front end. Is it going to be React.js or Next? Whatever. Just start thinking about it. But when I say vibe coders, might be, I'm talking more about non-technical people and maybe technical people too. Front end, of course, we know are the things we see in the software. The back end are the logic. When you click a button, what happens behind? You don't know, but something happens. When you say sign in, you don't see it saying I'm going to sign in now. Then you see an arrow that moves and signs in. No, you just click sign in and you sign in. Something happened after you click that button, and these are the things that happen in the back end. And when you click sign in, you have put in your name and a password, and this is also stored in the database, and it takes that and confirm, do we have this person in our database? And the database responds back to the back end, yes, we have, login or sign in successful, and you continue. Then we now start going through the tools that support this process: planning, design, AI coding, the dev tools, the front end, back end. There are so many tools you can use, you can choose from. So for planning, I would say for me, I like GitHub projects. I use it. You don't have to. You can even use a paper, your book, your notebook to plan. You start designing. You can use you can use Figma. There are so many tools you can also use to design. Like, how do you want the front to be? When people log in, what do you want your landing page to be like? You start designing. AI coding, which one? Just pick anyone and stick to it. There's Cloud Code, Cursor, Copilot, Windsurf, Replit, Gemini. There are so many tools. Just pick one and stick to it. You can research and find out the one that works best for you. Dev tools, there is the front end, there is the back end. Here is the databases. There is also the deploy tools. Since we are just starting, you have to look for something that is minimum when it comes to cost. Vercel is a good one. They have the free option if you are still in the initial phase. Yes, it's free to deploy in Vercel. But when you're now going commercials, people are paying for your app, then you should upgrade to, I think they have the $20 Pro for a commercial application. Then there is the ops and deployments. There is for your CI/CD. You can use whatever, and for monitoring your applications, there are so many things you can use for that. So building with AI the smart way. A simple way not to do it is build a quiz app. Paste code. You don't read it. You just ship it and hopes nothing breaks. Don't do that. Make sure. You might not even understand what the logic is, but it's okay to scan through. And when you're scanning through, what are you scanning? You ask, what am I looking for exactly? You might not know what you're looking for, but the more you go through, the changes it's making. And the key thing to be looking out for is making sure that is telling you what it needs to do. Like, this is what I'm building. I'm building how to pull the quizzes, or where the questions are stored, how to pull it. You start reading and making sure that it's not adding anything it shouldn't add, like any credentials or API keys that is not hard coded in your code. Just making sure things are not there. So you define your feature, clearly. You ask AI for a plan. Start with a plan is really important. Ask for a plan. Then you build things in chunks. Make sure you build, for the quiz app, if you're building how to, for someone to just enter C questions or select a category C questions. So this is the first plan. Build things in stages. Once you see that one is working, the categories are working, the questions are pulling, then you can move to the next thing. Can be maybe the login. You can just make sure that whatever you build is working. You test it, you review the code, commit your changes, and you can move to the next thing. Next here is the version control. So if your app is not in version control, it is not under control. Version control, what is version control? Is a way of being able to have a track of your changes. If I write something and tomorrow I make a change and my app is broken, what do? I can roll back. So how do you roll back? You will roll back to the previous version that is working. Then you now start troubleshooting and looking for the bug in the latest code that you pushed. So if you have something version controlled, if you have a record of the sequence or how the changes are made. Imagine I have a notebook and I'm writing something, and like, okay, tomorrow I have something new to write, and I write it. And if something goes wrong with the new information, I can go back to the pages and say, oh, this is the information I had before then. But if I have a new information, I decide to tear this out and trash it and throw it away. If something goes wrong with the new information, am I able to go back to the old information and get what I was doing? So this is what happens with version control. And make sure with version control you have branches. So branches is where you have, say, oh, I'm in dev mode, I'm building, this is development environment. After that, you can move to staging and also move to production. So production means, is now ready for users. Staging can still be a place where you have QA, people to test it and tell you, give you feedback. You still go back and forth with dev and staging. But when you're satisfied that things are good, then you can start moving things to production. Testing is non-negotiable, so make sure you have your tests done. If you're writing your app with an AI tool, make sure you tell the AI to break the app. See if it can find vulnerability, see if it can also break it. You can also ask human to test it. So when I say human to test it, it means I log into this app to play quiz. And if I leave and sign off and open the app again and I'm seeing I'm still on, whereas I signed out, why am I still on? Or if someone signs off, if you start seeing things that shouldn't be seen, or I answer quiz and the score of yesterday is added to the score of the next quiz, things like that. If it's not functioning well, people will start telling you, giving you feedback. So it's really important to, let people give you feedback, and also add your unit tests, things that test your app and make sure that it functions the way it's supposed to function. So when I say test, you have to write a test. So write a test in your application. This goes in the process, is all included in the cycle. Build application, it checks the application, it tests it. If it's good, then it builds it, then deploys it. So it's non-negotiable. You should make sure you have tests for your application. And next one is a security and validation. Make sure you're checking for authentication or authorization, security management, or the secret management. You're looking for validation, password hashing in the database, also rate limit. Can I play your quiz all day and play it? Well, I paid $5 to use your quiz, then I expect that I will use, even with the AI tools. If you pay for Claude, does not mean you're using Claude 24/7 for the 1 month that you pay $20. There's a limit. You can even use it in a day, and it tells you, well, it will renew the next day. So these are the limits you put on your application so that it is not overused. Or you can have categories that if you know you can use it more than this, then they should have categories of payments or categories of people that can use it. So back to the secret management. You don't include your secret files in your application build or in the CI/CD. There are places you can start saving. If you're building in the cloud, they have environmental variable files where you can add your secrets. This file doesn't go with your application code. This file goes differently. If you see codes that are pushed in GitHub, you see it doesn't come with the .env file. .env file sits in the local. Then if you want to run this application in AWS, you can go to AWS Secret Manager SSM and add your secrets. You add it differently. Then your application will go go to the secret manager and pull the secrets and use it for the application. So it doesn't move with the code. So it's somewhere it has to be local. Then you have to go add it where it's supposed to be. Next is deployment environment. I've been talking, starting this in local development. From there you move to staging, and from your staging you move to production. Dev is sometimes locally. If you're running, you make sure you have Docker running. Well, that's a big word if you're a vibe god or non-technical, but you make sure that things are running locally. Everything is good, then we can start moving to the staging environment. Then from there we can start moving to prod. All right, next is our CI/CD, shipping with discipline. So CI/CD is continuous integration, and the CD is continuous delivery. If you're in project management, you understand what a waterfall is. It's linear. You start application and you start planning until you finish. But with software, you have to. Is a cycle like a CI/CD. If I make changes on the code and push to the version control, once it detects there is a push, it starts building. The test is running. If the test passes, it will build the application. If the application is done building, it will deploy. And once it's deployed, all my monitoring tools are monitoring the application and checking how they are performing. And so this is what we call our CI/CD pipeline. So I will run this pipeline for you to see how it goes. So it's checking for the lanes, it's checking for the format of the code. Is everything good? It checks for the unit tests, it checks API, it builds, deploy, and it checks if it is actually healthy. Are people accessing the app? Or the system will check if the app is accessible. Then it will tell you, it's healthy. Then also people will also verify that for you. If your application is now running in production, deployment is not the end. It is the beginning of the operation. So you have deployed, operation starts. So this is where all the data from your application is now coming from. The login, when people click the app, how many seconds does it take the app to open? When they click this button, it starts tracking all those things. And metrics, checking the CPU of the machine that is running your app, checking the memory, and also checking the error rates, and checking your start going through your observability. How is your app working? And for your data, you also have to have backup. So if people are you have to always have a snapshot of backup. Also set up with disaster recovery. If something happens to your application, are you able to still retrieve the data in your database? Set up a system that takes snapshots of your database every day. And if something goes wrong, because we have a version control, if something goes with the current running application, we can always roll back to the previous one, because it's version controlled. All right, and we also have to think about uptime. So uptime means how many percent is my application up. So up means it is running, is available. So if I have to determine, for uptime, I want my application to be 100% up every time people access it. That's the goal. But usually people just set it at 99 point something, because there are other factors that can affect your application. You're running it in the cloud. The cloud can go down, something can happen to that region, or something can happen. So you just have to promise, what is doable or what is achievable. Yeah, the goal is 100, but it can be it can be up, but you just have to determine like what is obtainable for that region for your application. You also have to start defining so many things, criteria about the service level agreements, the service level objective, and start the objective, the indicator, what would tell me that my application is performing well. If it is available 99.5%, it means we're doing good. But if it is maybe 90, well, that's not good at all. All right, so software is never finished. I tell you this, once you have your MVP, which is the minimum viable product, once you have that shipped, this is where you start going back to now start making new versions. By the time an application gets to you, maybe it's already in version 4, because they have done some testing, gone back and forth before they are ready to send this application to the users. But you see that first part, which is the MVP, you really need to get that fast. You really need to get it out fast so that people can start testing it, and not people like random, but testers can start testing it and giving feedback for you to go back and forth. So for this our quiz application, the MVP, I told you the minimum will be, have 10 questions ready, category, the score screen, answers review. Then we'll start, fixing bugs and fixing or adding features to application, and also doing dependency and security patches. What is that? Dependency check. If, for instance, I'm running Python, Python is in my application somehow. Python 3.12, and tomorrow they are not AWS. I have my application in AWS, and AWS is no longer supporting Python 3.12. I have to upgrade the Python in my application, and things like your infrastructure, your computer that is running, sometimes you see, there is an update to your computer. The same update also happens to those computer or the machines in the cloud or your infrastructure. So you have to always make sure you updated security patches, the libraries or dependencies in your application, that they are up to date. And if they are not, you have to upgrade them and make sure that each one is compatible with the other, and things like that. So you go to your version 2, you start adding more things, your user account, leaderboard, you start adding the difficulty levels, like different levels, like the easy one, medium, difficult, very hard. You can start adding those in versions. And your version 3, you can start adding the multiple player, the AI generated questions. You can start adding premium tier, like maybe you can have different tiers for people if they want to be living 24 hours in the app. You have to have categories and limits for people. You can now move from web app and maybe move your app to a mobile app, and that's a big win. So what vibe coders must know, you must know this. You don't need to memorize syntax. You don't need to know every line of code that the AI is giving you, but you must know how software works as a system. You have to understand how it works, understand the big picture, understand the basics. You don't have to memorize, but you have to understand the logic. What is going on? If it's writing a test, is this the right test? You also have to ask it. Even if you don't know what is writing, ask it, explain this. So just having an idea, if something breaks in your code, how do you know where to go fix? If people are complaining about this, because most vibe coders, it's just one person building, so you have to know how it works, so that if something goes wrong, you know where to go check or where to go see that something is going wrong. Break any idea into features and user stories. Have an idea, start breaking it down, define your MVP, you understand what front end, back end, and databases, what it is, understand the layers and what they do. And just to say it again, front end are the things you see. If I open an application on my phone, I will say, oh, this is what I'm seeing. For instance, I will go to a quiz. This is a game. This is the front end. I can click on this. I can see this is front end, and when I click this, what is going behind it is back end. The logic I'm not seeing. And database could be, oh yeah, I'll also show you what a database could also be doing. In this app, you can say, oh, I've played yesterday, and I played on the 2nd, and I played today. It remembers that I did something. So some of these are stored in the database. Even if I uninstall the app and install it again, and I might still see the same thing, because it is saved in the database. And read and comprehend, try to understand the code. Even if you don't, like I said, even if you don't know the syntax, just understand the logic. Write the test. Make sure it's writing the test. Make sure you use Git. You're using version control. And when I say Git, commit small. Make sure that every small change you make, you commit it and be sure it's running, it's deployed, it's running. Then you can add changes gradually. Don't add a lot of changes and tests and push, and you see things are broken, but you don't know what is broken. So the smaller chunks you commit your code, the better for you. Debug errors instead of reprompting blindly. If something is wrong, what is wrong in the code? Don't just say, oh, this is wrong, rewrite it. It can rewrite a whole lot of things. And sometimes I think even AI doesn't even have memory to remember, oh, this is. Ask it, okay, what change are you trying to make, so that you see it. Don't leave your AI to be making changes blindly without you approving them. So protect your secrets. Make sure that the secrets, your API keys, credentials are saved in the right file. And if you have your credentials, your secrets in .env file, AI is not going to write or read that file. It's only visible to you. Maybe, I don't know about OpenClaw, or maybe agents, I don't know about if they're eventually going to have access to it. But the way it is written, they are not allowed to read or write in those files. It might tell you, add your database URL it will tell you to go add it. Then you go create a database, copy the URL and add it. It might ask you, oh, if you want a payment system, go to Stripe and create it. To give you the instruction, you go to Stripe and create it, copy the API key, then you add it. It can pull the file it can pull the env file during build locally, but it's not able to write or read that particular file. So deploy safely with proper environmental separation. Make sure you have local, finish with local tests in staging where humans are testing. You're doing feature tests before you start going to production. Monitor your application in production. Don't just deploy and believe everything is good. Monitor, not monitoring if it is working, monitor how it is working. What is the login system? How long does it take people? What is the latency? Is it too slow? Is it too fast? Fast is good, but if it is too slow, how fast do you want it to be? This is monitoring. It's not just how the application, if the application is, how the application is performing. Improve your architecture over time, not all at once. If you start with being minimum when it comes to budget, once your application start growing, please, you have to start scaling your system, scale your architecture. If you're using a free database, you have to start maybe using a paid one, or making sure you have security patches, you have all the required architecture or all the required configuration for all the things running your infrastructure. All right, so common vibe coders mistake. Well, I might fall short of some of this. You build too much too early. don't build too much too early. Just start with the MVP. You might get overwhelmed when you're building a lot. Just make it small and gradually start scaling. You're trusting AI output without reading or understanding it. Try to understand you don't have to memorize, but try to understand. Ask your questions. Don't skip tests. Make sure you, no matter how simple the app is, even if it's just, what's the simplest app? A note app is not simple, but note app is just, to write notes. Make sure that when I'm writing, the lines are the way they're supposed to be. Just test whatever it is. Make sure your version control, your application is version controlled. It's going somewhere, and make sure you're able to not just leave everything in your local computer. If it's version control, you can always pull your code, you can always clone them, you can always bring it back to your system. Something might go wrong with your system. So what next? Don't hard code your secrets. Deploying without any monitoring or error tracking, using too many tools too soon. Don't overload yourself with too many tools. If you want to vibe code, Lovable is good, Cloud Code is great. There's so many tools. There's Replit. There's so many. Just pick one and stick to it. Don't be trying ideas. You can try them for ideas, like with plans. You can try different tools, but once you have a plan, start using one to build. Also, copying code that you don't understand. I fall short of this. Before you copy a code or copy commands, understand what it means, what it does, or at least in a high level, what it does. Building only for demo. It ends with you and maybe few people you're demoing your app to. Also be preparing your app to be used by people. Confusing it runs on my computer, which is production ready. That it runs on your computer doesn't mean it is ready to go into production. So that's just things to have in mind. And this will be my last slide. It's been a long one. Make sure you understand what you're trying to do. Software is more about engineering it, structuring it in a way that, okay, this is where we are starting and this is where we are headed, and when we get there we can start improving and start adding features. A software doesn't end once you have deployed it. You still have to keep making changes. Things are changing every day. Like, you're seeing new tools, you're seeing, you can do this, you can do that, and you don't want your app living in the stone age. You want your app to move with the generation. So you have to always be in the know, be learning, and also be improving your application and make sure that people are seeing it. If you followed me up to this point, I really love you to like this video so that I can reach other people. Comment your ideas. If there are things you're trying to build and you want us to do this together, you can comment your ideas. You can start building it. Join a community too that can motivate you into building your application, that can also motivate you into pushing your application for people to test it out there, for people to give you feedback. And I would love to see you next time.